I'm Ro, a co-founder CEO of Carmera. I'm just gonna go ahead and kind of get out of the way kind of the main characteristics and sort of vital statistics of our company. So our mission is to automate cities with the world's most robust real-time street-level intelligence platform and accessible to anyone. We have three main product suites, which I'll take you through. There are North Star, our flagship product suite for autonomous vehicle navigation. We also serve built environment types of uses with a suite we call Carmera Site Intelligence. And we also provide a service to urban fleets with a fleet monitoring service, which is actually largely a means to an end to produce the other products that I mentioned. We are based here in New York, in Brooklyn. It's our main office. We also have a Seattle office. In terms of the DNA of our company, it's a sort of a mix of people like myself. I have a transportation background, a data background from a couple companies. A lot of our team actually is from MakerBot. My co-founder, Justin Day, is a CTO there. All our first engineers are from there, some of our investors as well. And then we also have quite a bit of mapping and computer vision, machine learning talent, as you might imagine. We're venture backed. We raised a Series A last year with Matrix and a bunch of other East Coast and West Coast investors, some international as well. And like I said, we're mainly based here with an office in Seattle, but we also have operations in other parts of the country and internationally as well, namely in Asia right now. So let me get to the good stuff here. I'm going to go pretty quickly because there's a good amount to get through, and I want to try to save room for questions because unfortunately I have to leave a little early this evening. But anyone know what this is? Anyone know? This has kind of become a familiar image in our space. This is, I think, the first ever look at what a HD map for autonomous vehicles actually looks like. I think it was 5-6 years ago, Google started being more public with what the hell they were up to in Mountain View with these self-driving cars. And they showed the world that, hey, we're building these maps as part of the stack. Fast forward to today, almost every serious AV program of any kind tends to rely quite heavily on high-definition maps that machines read in order to navigate safely, and really for two reasons. One is for redundancy and certainty in terms of what real-time sensors are seeing and comparing it to what the map says should be there. And two, for foresight, which is actually useful for even regular driving, right? So just to know what's around a corner or 3 blocks away. But one problem was quickly emerged in this space a few years ago when I was starting to think about this. I have a autonomous transit background myself from like decades ago, but kind of the mapping problem became pretty clear that there was like a couple companies in the world that were investing just immense amounts of capital and resources to be able to build these maps at scale. There are a couple incumbents in the space that were also trying to move in that direction from sort of standard definition automotive mapping to the next generation, but kind of hampered by very sort of long or legacy, slow, costly infrastructures. And then also there's the open movement in mapping, which is great. We're big believers in it, and we utilize OpenStreetMap and derivatives of it. But for this purpose, it just wasn't built for this purpose, right? It's just too coarse. Just purely crowdsourcing these kind of maps from just regular consumers doesn't really work. So we set out to really work on, again, what we call real-time street-level intelligence platforms, with autonomous vehicles being the end goal, but also to serve other sort of smart connected cities types uses, which I'll show you in a second. And what we also decided was mapping for this purpose is really most critical in more complex environments. They're both harder to build there, and they're more useful there. So we wanted to figure out if we could scalably, efficiently build these maps more deep, more fresh, more cheap. And the approach we took was sort of this two-part approach. And there's actually a longer version of how we got to this, which maybe I'm happy to talk about later. But basically, what we do is a combination of first-party high fidelity base mapping of streets. So for example, this vehicle you see here, it's lives in a garage in Brooklyn, and we call it Carmera Force One. It's the first mapping vehicle we put together with LiDAR, spherical camera, high-end GPS, the whole works that you will see on a mapping vehicle that you might see around a city. And that gets a high-quality base map of the streets at anywhere from 2 to 10 centimeters. But the more novel approach to how to actually scale these and keep them fresh was when we started talking to fleets, professional fleets that serve cities, and we realized we could provide them a valuable service in terms of monitoring their vehicles, keeping them safe, and in doing so, get really valuable data as sort of a change detection layer on top of our base map. So I can actually, unfortunately because of the tech reasons, it's a little awkward because I'm not driving, but hopefully they can show you an example of this in real time. Can you guys switch? So this is, no, the one before this? Can you go to the one before this? Yeah, so this is an example. This is one of our fleets. The dashboard they get, it's one of the ones in New York who let us demo their dashboard. It's kind of the end of the day, so most of them are starting to go home, but you can see a few of them are out still. So we provide them this telematics dashboard for real-time tracking of their vehicles. We provide them safety stats and tell them how, basic things like how long their drivers have been on the road. But then if you go to the next window, really the main piece of what's attractive to what we're doing for them is we're actually installing visual sensors on their vehicles. They're roof mounted, facing forward, sideways, and they're taking HD video all day long. And what's really useful is, it's chaos out there, and it's actually really valuable to be able to do dispute resolution or driver coaching or fighting a parking ticket, whatever, when you have the video, especially for these professional fleets who have very large sort of risk profiles and insurance costs, parking ticket costs, et cetera. So if you go to the next window, or actually go to the QuickTime, here's an example of if you had clicked into one of those links from the earlier screen, this is what they're able to get in their dashboard if you press play. So this is nothing really notable here. It's just one of the Sprinter vans actually from one of our fleets driving around, I think in Greenpoint somewhere. So pretty standard. If something had happened here, they would be able to go back to the video and use it for whatever incident resolution they wanted. So if you then go back, please, to the presentation. Thank you. You can see what we do. That same clip I just showed you. Let me see if this works. No, it didn't work. Can you press play on that video? Oh. Nope. Yeah, right there. Thanks. So all of that data we're collecting, we run it through MLCV algorithms. This is a particular neural net that has been really effective for us. And it's especially good at a lot of the things you see, but a lot more actually. So pedestrian, vehicle, bicycles, traffic lights, signs, dogs, handbags, all kinds of things. But some of the things are useful for us, others aren't. But if you then, let me see if this works. Can you go to the next slide? I can't do it from here. Thanks. So in combination, if you remember those two ways of getting data, basically what we're able to do then is get these really accurate 3D reconstructions of the streets all over a city, and also the kind of the raw video from the sensors that we're installing on our fleet partner vehicles. And we have a combination of sort of a very high accuracy geometric model of the dimensions of the streets, as well as annotations on top of it that we're able to either machine tag, or in some cases we also use humans to verify them. And we're able to get it at scale on an ongoing, continually updated basis. So that's actually old, but like in New York, for example, where we started, it was probably actually 6-9 months old. We're even denser than that, but that shows you in the very highly yellow spots, that's where we're getting a new look on that street every couple days or so. Whereas in the more orange-red spots, that's more like in the last month or two. And so that sort of approach has worked really well for us. And that's also, it's sort of, we as a startup, we kind of didn't have a choice, right? You can't just brute force yourself into mapping every road with, $50,000 worth of LiDAR or something like that. So what we, part of what we do with that data is we actually make it available for non-automotive use cases. I mentioned our product suite we call Carmera Site Intelligence. And this is an example. This is actually not the product. This is just a visualization. If you can press play on that video real quick. This is an example of one of the types of analytics that is actually really useful for our autonomous vehicle product, because what we're able to do is take that, for example, that pedestrian detection and snap it to the edges of the road network and build a longitudinal model over time when we have enough observations on each street to get a really robust, in this case, pedestrian density model of the entire city, which is really never existed in terms of based on actual observations and going back historically. So this is an example where we actually gave this data to NYU. They did this viz. I think I just missed it, but they wanted to see, for example, when classes got out at 2 o'clock, if you could see it in the heat map, which sure enough you could. And then I think again at 5 o'clock, you'll see that happen again around the NYU area. And to fast forward today, this is something we're actually working with now with, for example, commercial real estate firms to help them make better decisions on things like site location. But really the main thing that these are all the building blocks. If you can go to the next slide, please. These are all really just the building blocks to the integrated living high definition map. So if you press play on that, this is just an animation to kind of show you from our data. This is, I think it's a street in Brooklyn somewhere that we 3D scanned. And then if you could fast forward towards the end of the video, maybe at like the 30-second mark, just for time, you can see at the end where all of the kind of semantic segmentation and the markings, the signs, the lane level routing graph, all of those have to come together. And that's sort of what an autonomous vehicle needs to know in addition to its real-time sensing to be able to navigate safely. So now that is really hard to do even at a small scale, and to scale it is really hard to do, right? So if you go, if you can skip to the next slide, please. So we had to figure out a path that we could actually, again, as a kind of a resource-constrained small company, do it in a staged manner and still provide value at each step. So this is broadly kind of the framework we came up with on how you can actually build autonomous vehicle maps scalably, affordably. And I kind of already mentioned there's sort of 2 parallel paths where you have sort of a base level scanning, reconstruction, mapping pipeline. And then on top of that, you have sort of the change detection piece. So what we call crawling, and then looking for sort of attributes of the road, translating them into semantic information on the road that a vehicle wants to know, and then also seeing when those things change. Ultimately, that is what builds our sort of flagship North Star Carmera Autonomous Map Suite. But to get there, like I said, we kind of had to figure out this stage approach. So the first thing was, all right, well, we can do scanning by ourselves. We can build our own rigs, or we can use third parties to like surveyors and stuff to scan for us. But how the heck are we going to get, like basically build like a web crawler for a city to then get the change on top of that? So as I already showed you, our first epiphany was, well, we think we can actually provide value to fleets that are already on the road with the telematics product. So, and that ended up working actually really well for us pretty early on. The next thing was, well, before we're able to kind of get all the parts working together and also compatible with what basically a robot car can consume as opposed to someone else, can we provide value in other ways? And that's when we started looking into that second stage where we were starting to talk to people in the built environment space, so people in construction and real estate and planning. And sure enough, we got feedback that, if you just gave us, some of the 3D point cloud data, we could use it to help, redesign a facade without having to go out there ourselves. Or if you gave us the pedestrian analytics, that would be really useful, because right now it's just finger in the air, or someone clicking a counter to do this kind of stuff. So again, that was something that was really helpful for us to sort of imagine how we bridge that journey. And And actually, fast forward to now, we're starting to actually see how those dots can really be connected, where when, on one hand, there are individual standalone customers for each of those things I just showed you, but we're also seeing how, in an integrated fashion, whether it's a city or whether it's a community of some kind, it might be a office park or whatever, they tend to actually have all those types of needs. They tend to have security maintenance vehicles that are going around their property. They tend to have needs for planning and sort of site analysis data. And now you're seeing people starting to really rethink how mobility happens in their sort of their zones, their areas, and of course, autonomous mobility has become really sexy and intriguing for a lot of those types of communities. So I guess I can't unfortunately go too much more into that, but stay tuned, I guess I'll say, because there's some exciting things in the works there. Finally, I'll sort of, before I get to some lessons learned, I think the other thing is we found that there's also a longer tail of use cases, and really most of them, this is actually not an exhaustive list, most of them we don't have a resource to actually productize ourselves. So, there's a few that we have kind of committed to, but there's kind of a longer tail where, we're starting to kind of package our API so that it's easier for third parties to be able to tell us that, okay, can your data actually be helpful for some of these other uses that, we think they could. So let me end with a few, so just a few lessons learned about doing a hardware company like this, and in my, IMHO stands for in my hardware opinion in this case. So first of all, this may sound like heresy, but I would say don't build a hardware company. I would say if you're thinking I want to build a hardware company for the sake of a hardware company, personally think that that's the wrong way to think about it. You think about, start with the problem and just sort of be agnostic about how you get there. If it involves hardware, great, but you really need to be sort of ruthless about that. Second is really I think you guys may have heard this, but trying to focus the business not necessarily tied directly to the hardware. It's just clear that the business models that are more like hardware enabled as opposed to hardware centric are the ones that are winning. Next, that said, we found that talent that's sort of drawn to both hardware and software tends to be awesome. So that's been a really good signal for us. Even if you have a bunch of people who really like hardware, but you're becoming more of like a data or software company, Hack Weeks have been a really good outlet for that, and sometimes can lead to really interesting projects. And then finally, let me just go through these really quickly. I will say also, we've learned to sort of find what we call our SpaceX path. Yes, figure out what your Mars is, but also figure out what your cargo runs are to fund getting to Mars, and also prove out your reusable rocket technology, which is kind of what I showed you before. Same thing with whether are you building an asset or are you actually building a business. Try to have a plan that's plausible for both, even if you can't do both at the same time. Finally, I think I already mentioned, we sort of have a North Star focus and 1 or 2 ancillary products and then an API. I think that's pretty much the most I would recommend trying to do all at once. And actually, finally, the last bullet on this slide is there's a Paul Graham essay called Schlep Blindness. You guys can Google this, but basically what it refers to is there's a lot of problems out there that people are they're kind of unglamorous, and people aren't willing to get up on a ladder in January and put a sensor on a Sprinter van. And so I would encourage, sort of looking for those if you have the will to deal with that, because I think we found a lot of opportunity there. And that's it. I'll wrap up. Thanks a lot for listening.
Thank you very much. We'll jump directly into questions if we have some.
So I think the bigger question is, when you're building autonomous vehicles or something for autonomous vehicles, did you go to the big car companies or have you held off on that until you felt like your technology was really scalable? And if you have, were they receptive to you, or did they kind of push you away?
Yeah, so the answer is yes. It's a sort of a combination of you, yes, I mean, you should be talking to people early and often. The thing is, the state of this industry right now, it's so R&D centric, right? So like, even the people farthest along, you would still consider them at an R&D stage. So by nature, it's actually a good thing, because they are trying to solve problems just from a pure like technical, sort of the purity of the technical problem. And so if there's a solution out there that they haven't seen yet, they're usually willing to listen. Now that said, working with a huge car company and going through the hoops, especially going from like a testing type of, sort of environment to something at bigger scale and then ultimately to production is a long path. So, one thing that we've also seen is there's also a sort of a kind of a bottom-up approach we're seeing where there's kind of a dual tracks. There's the big car companies doing their projects. Some of them are doing, like urban types of fleets, AV, but a lot of them are actually playing catch up to Tesla Autopilot, basically. And then we're seeing a lot of companies a lot of them are startups too, that are just focusing on more like contained environments, like I said, like amusement park or college campus or something like that. So that's nice because you can get a lot more sources of feedback when you're in the early days.
So let's do just one more.
Hey, thank you. Very interesting presentation. So if you're not a hardware company, but if you build a hardware company and you have the hardware on the vehicles, do you see, but the vehicle manufacturers are very sensitive to adding any cent, they'll save wherever they can. Do you see this as a difficulty, as this is, expensive hardware, however much you reduce the cost for autonomous vehicles? Do you see the hardware actually sitting on the vehicles or ultimately something on the road running it instead of having an autonomous vehicle, more of a driverless vehicle? And where do you fit if that's a different vision?
So I couldn't catch all that, but okay,
sorry about
better.
that.
But were you asking about whether
do you think ultimately the sensor will be on the vehicle?
Yes, okay, that's what I thought you were asking.
Whether will it be really autonomous or driverless? The sensor will be somewhere else because they're so sensitive to adding any cent to the cost of the vehicle.
Yes, although there's a couple answers to that. There is absolutely BOM sensitivity, especially for the Teslas and Cadillacs and Audis of the world who are basically building level 2, level 3 autonomy components, and really they're just super luxury cars for now that only very rich people can afford. But yes, I think that'll continue. There'll continue to be pressure on that going forward. However, I will say for the more kind of fleet-oriented approach, so like robotaxis basically, the nice thing about that is they're a lot less BOM sensitive because really the economics rely mostly on the OpEx as opposed to you can still have a robot taxi with $100,000 worth of sensors on it and economics could still work if you have enough passenger mile density per vehicle. But I think the other part of that question I think was is it really just going to be the sensors on the vehicle that are ultimately going to be doing this mapping? Is that kind of what you're asking too? Yeah. Yeah. That was something that we definitely, had lots of questions about before committing to even doing this company. But it became clear that even there's really, I would say, 3 main companies that have seriously committed to doing mapping in-house and are actually quite good at it and are continuing to invest in it. And even they still acquire third-party data and still, they'll do separate mapping runs just for the sake of mapping outside of actually driving a passenger around. Mapping, I think, especially just in the last 6 to 9 months, most of the OEMs and the other companies have realized it's really hard to own yourself. So to answer your question, yeah, I think we absolutely have an architecture that allows us to ingest probe data from our own customers. That's great because that makes the data better for everybody. But we deliberately wanted to, if you noticed our approach, we didn't go into market saying, hey, just work with us because we have a bunch of software that you can plug in and it'll make maps in your car. We wanted to be able to serve projects or customers independent of having them give access to their probe data to us because that's just another friction point that we didn't want to have to deal with right off the bat.
Great. Thank you very much, Rob. Appreciate it.
Thanks.